Hi guys! Welcome back to my channel. For today's video, we're going to make a summaries on chapter 9, which entitled Transport Layer. Chapter 9 includes 9.1 Transport Layer Protocols, which is explain how transport layer protocols and services support communications across data networks. Explain the purpose of the transport layer in managing the transportation of data in end-to-end communication. Explain characteristics of the TCP and UDP protocols, including port numbers and their uses. 9.2, which is TCP and UDP. Compare the operations of transport layer protocols in supporting end-to-end communication. Explain how TCP session establishment and termination processes facilitate reliable communication. Explain how TCP protocol data units are transmitted and acknowledged to guarantee delivery. Describe the UDP client processes to establish communication with a server. Determine whether high reliability TCP transmissions or non-guaranteed UDP transmissions are being suited for common applications. So let's start in 9.1, which is transport layer protocols. Role of the transport layer. It is responsible for establishing a temporary communication session between two applications and delivering data between them. Link between the application layer and the lower layers that are responsible for network transmission. We can see the enabling application on devices to communicate, application, transport, internet, network access. The transport layer moves data between applications on devices in the network. Tracking the conversation. It tracks each individual conversion flowing between a source and a destination application. Segmentation divides the data into segments that are easier to manage and transport. Header, used for reassembly is used for tracking. Identifying the application ensures that even the multiple applications running on a device, all applications receive the correct data via port numbers. There is a multiple web pages, instant messaging, online video chatting, streaming videos, and email. The transport layer tracks each individual conversation flowing between a source application and a destination application separately. In this conversation multiplexing, segmenting the data into smaller chunks enables many different communications to be multiplexed on the same network. Segmentation allows conversion, multiplexing. Multiple applications can use the network at the same time. Segmentations facilitates data transport by the lower network layers. TCP/IP provides two transport layer protocols, which is transmission control protocol, whereas TCP, and UDP, which is user diagram protocol. This does not provide for reliability, fewer fields, and it's faster than TCP. TCP transport is similar to sending track packages. If a shipping order is broken up into several packages, a customer can check online to see the order of the delivery. Numbering and tracking data segment, acknowledging received data, retransmitting any acknowledgement data after a certain period of time. This is the three responsibilities of TCP. This is the overhead, and to reduce possible delays, best effort delivery, no acknowledgement, similar to a non-registered letter. TCP database web browsers and email clients require that all data that is sent arrives at the destination in its original condition. UDP, if one or two segments of a live video stream fail to arrive, if disruption in the stream may not be noticeable to the user. TCP features. connection-oriented protocol ensures the application is ready to receive data, negotiate the amount of traffic that can be forwarded at a given time, reliable delivery, ensuring that each segment that the source sends arrives at the destination, same order delivery, numbering and sequencing the segments guarantees reassembly into the proper order, flow control, regulate the amount of data the resources transmit. TCP header, source and destination port used to identify application. Sequence number used for the data reassembly. Acknowledgement number indicates data has been received and ready for next byte from source. Header length, control bits, window size, and checksum. Source port, originating application port that is dynamically generated by sending device. Example, each separate HTTP conversation is struck based on the source ports. Destination port, tell the destination what service is being requested. Example, port 80 web services are being requested. These different applications, protocols, transport, and port numbers. Socket pairs, source and destination port placed in segments encapsulated in IP packet. IP and port number. Example, 192.168.1780. Sockets enable multiple processes to be distinguished. Source port acts as a return address. (9.2) The TCP and the UDP. As you can see, there is a client sending TCP request destination ports, and the request source ports. The TCP server process. Server responds to TCP client uses the source port from the source request packet as the destination port. The response source ports is server responses to TCP client uses the destination port from the request packet as the source port. Step 1. Initiating. Client requests a session with server. Step 2. Server acknowledges and requests a session with. Step 3. Client acknowledgeable communication session with server. To close a connection, the finish or fin control flag must be set in a segment header. To end each one-way TCP session, a two-way handshake consisting of a fin segment and an acknowledgement ACK segment is used. To terminate a single conversation supported by TCP, 4 exchanges are needed to end both sessions. The TCP three-way handshake analysis. The three-way handshake establishes that the destination device is present on the network, verifies that the destination device has an active service, and is accepting requests on the destination port number that the initiating client intends to use. Informs the destination device that the source client intends to establish a communication session on that port number. The 6 bits in the control bits filled of TCP segment header are also known as flags. RST flag is used to reset a connection when an error or timeout occurs. This is the TCP three-way handshake. The SYN, ACK, and the ACK. Congestion causes retransmission of lost TCP segments. Retransmission of segments can make the congestion worse. To avoid and control congestion, TCP employs several congestions handling mechanisms, timers, and algorithms. Example, reduce the number of bytes it sends before receiving an acknowledgement. UDP not connection-oriented, not retransmission, sequencing, and flow control, functions not provided by the transport layer implemented elsewhere. UDP reassembles data in order received and forwards to application. Application must identify the proper sequence. Note that the remote authentication dial-in user service or radio server shown in the figure provides authentication, authorization, and accounting services to manage user access. There are three types of application best suited for UDP: live video and multimedia, simple request and reply, handle reliability themselves. 9.3 Chapter Summary. Explain how transport layer protocol services support communications across data and networks. Compare the net operations of transport layer protocols in supporting end-to-end communication. And that's all. We're done in chapter 9 for the summaries in CCNA. And I hope you like it, guys. So please don't forget to subscribe and click the notification bell so that you will be updated on my other videos that will be uploaded. Bye, guys!